Alrighty, so in this video we are going to stub out our Async API. So the vast majority of our Async API is going to be, well, actually the entirety of our Async API is going to be two classes, our deferred and our deferred of T. So if you remember from the last video, we talked about the deferred API, which is used to handle asynchronous operations, which is it's used to represent a long-running operation that can be combined with other operations to do awesome things. And you'll notice a large part of the client, the server, and the communication between the client and the server, and between the two servers, uses the deferred API. So what I really wanted to do is I wanted to take the concept of a deferred and turn it into a C# class that can be reused between the client and the server. So I based this implementation largely off of the jQuery promises or the Node.js promises. And if you're familiar with JavaScript and you're familiar with those libraries, this will look very familiar. The biggest difference is that we're just writing a deferred class. We're not writing a promise interface. So yeah, what you see right here is is a console application I just built targeting .NET 4.6, irrelevant which version of .NET I'm targeting. What we're going to do is we're going to write out our classes in this project, and we're going to show off a couple examples of its usage and test them out, and then I'm going to dump them back into the buzzmmo.base.infrastructure namespace. Now, you're more than welcome to develop these classes in the buzzmmo base infrastructure namespace if you want to, and then use unit testing to kind of test everything out. But I thought from a teaching perspective, it would make more sense to do this in a console application so that we can kind of watch the execution with the console window and make sure everything's working, because to test an asynchronous API like this, we're going to need to throw in a lot of thread.sleeps and all that fun stuff. But anyway, so like I said in this video, I just want to stub things out and get going. So let's go ahead and start off with our deferred class. So deferred. So the deferred class is basically the majority of where the deferred API is, and I'm going to be writing this in a little and kind of in a lopsided sort of fashion. We're going to start off with a static member. We're going to write our private fields, properties, constructors, and then our other static members, and then the rest of our members. And again, we're just stubbing things out. I want people to have an idea of where we're going with this and what the sort of structure of this is going to look like. So a deferred object, again, so hopefully you got an idea of how this works in the last video, but a deferred object is really a representation of an asynchronous operation. And that's really it. So a deferred object can have callbacks for when it's completed. It can have a Boolean indicating if it's already completed. It can have a Boolean indicating whether or not the request succeeded or not, and then a string error for debug errors. So yeah, let's go ahead and get started. The first thing I'm going to write is going to look really weird. It's not going to make a whole lot of sense. So we're just going to write it out, then I'll explain it in a second. It's going to be a private static read-only action of deferred called empty, and it's going to be assigned to def goes into empty block. So I'll explain this in a moment here. The next thing we're going to write is we're going to write our callback list. So I'm going to say private action of deferred callbacks, which looks kind of strange that we have a single delegate called callbacks, but it'll make more sense in a second. Next, I'm going to say public boolean, and we're going to say has result to indicate if it has a result or not. I'm going to say it goes into callbacks equals null. So you'll notice here that I'm using C#6 syntax. If you're not familiar with this, this is the equivalent of... So these are two equivalent statements, but one uses a C#6 feature. So one point to make here is that from this point forward, I will be using C#6 features, even in code that is shared with Unity. The only place I will not be using C#6 features is in the code that lives under the assets folder of the Unity project itself. The reason for that is that the C# compiler is the only thing that cares which version of C# you're using. So we can't use it inside of Unity, inside of the assets folder, because Unity's monocompiler doesn't understand C#6 syntax. But we can use it for the assemblies that are targeting .NET 3.5 in our base project, because then even though we're targeting .NET 3.5, the compiler is still the new compiler. So the compiler is going to take that code and turn it into valid .NET 3.5 IL, and then that assembly is going to be loaded up into Unity, and that's going to work just fine. But like I said, we can't use C#6 features within the Unity asset folder itself, which is kind of annoying when ReSharper 6 tries, or ReSharper 9, I think we're on, tries to get you to use C#6 features even if you're in the Unity's code, but whatever. Also notice that we are using Visual Studio 2015 right now to take advantage of the C#6 compiler. Anyway, so has results is equivalent to callbacks being null. We're next going to have a public bool is valid. This will be a more traditional property. It's going to be get private set, and we'll also have a public string error, which will be get private set. Now I'm going to go ahead and create a constructor real fast, and I'm going to say callbacks equals empty. And now I can start explaining what's going on here with our empty delegate and our callbacks delegate. So let's start off with the callbacks delegate. So it's odd that I have a single delegate called callbacks, because callbacks is plural, so that doesn't make any sense. The reason for this is that delegates in C# can actually, or in .NET rather, can have what's called an invocation list. In fact, this is how .NET events work. In .NET, events are nothing more than a wrapper around a delegate, just like how properties are wrappers around fields. And the thing is we can take advantage of the fact that our callbacks delegate can have as many individual callbacks added to it as we want to save memory, so that I don't have to instantiate a list or a collection or any other collection type in order to represent this. Now, I could use an event, but I'm not using an event, which would make zero difference, except for what we're doing here in the constructor. So in the constructor, I'm considering if we have a result to be if our callbacks has been set to empty, or sorry, set to null. However, in our constructor, I'm setting callbacks to empty, which is this guy all the way up here. Now, this empty delegate is just a method, is just assigned to a method that does nothing. And the reason I'm doing that here is because I need callbacks to be set to something, but I don't want to instantiate a new delegate to represent my empty delegate every single time that I instantiate a deferred. And here's another important thing about this implementation. I'm wanting to conserve as much memory as possible, because we're going to be instantiating a whole lot of these. They're used everywhere within the project, and we want to make sure that we keep its memory footprint as small as possible, which is one of the reasons why, for example, my has result, I'm not storing that in a Boolean. I'm determining if we have a result based off if the callbacks list is empty or not, or null or not, sorry. I guess null and empty mean two completely different things in this context. Maybe not the best name for it. But, so what we're doing here is in C#, in .NET, in order to add to the invocation list of a delegate, we have to make sure it's not null. So by making sure it's not null, we set it to this empty guy. And this empty guy is private static read-only, and there's only ever one of those objects ever created, which is good for us because now every time we create a new deferred, it doesn't create a whole new delegate for us, which in the, at the end of the day is not a whole lot of memory at all or performance, but this is just a quick little premature optimization that doesn't impact the readability of the code at all. I am also considering doing object pooling for my deferred objects. Like I said, we're going to use them a whole lot. They're going to be created all the time, and they're not going to be very long-lived. Fortunately for us, the .NET framework is very, very good at cleaning up short-lived small objects. So we might not be running into any issues. But in the future, once we get some instrumentation in place and we can start seeing if our deferred implementation has any negative impact on performance, we might consider doing something like object pooling. But anyway, so yeah, there's our public deferred. So there's a couple other constructors I want to make. I want to make a constructor that is used when we are considering the deferred to already be resolved, to already have a result. So we're going to have a deferred of bool is valid and string error. And then actually I'm going to do one above it. I'm going to do a deferred of bool is valid. I guess we can go ahead and implement these real fast. In this case, callbacks, I'm not going to set it to null because it's already going to be null. I'm going to say is valid equals is valid, and then here is valid equals is valid, and error equals error. So those are our three constructors, and they're used for, one's used for when our deferred has not been resolved yet. The second one is used for when it has been resolved to either being valid or not valid. And the final one is if it's been resolved to valid or invalid and it has an error that we want to attach onto it. I'm not going to impose any limits on the ability to have an error set even if the deferred is valid. I don't know if that'll ever come in handy, but it might, so I'll just leave that possibility in. Okay, so next up what I'm going to do here is I'm going to create some public static helper methods. And the reason I'm doing this is for code readability. So these methods are going to be very, very simple. And so fortunately, though, they'll most likely be inlined anyway. And so we don't have to worry about the performance impact of invoking these methods instead of the constructors directly. But I think by creating these factory methods up here at the top, it'll really increase the readability. Because, for example, I mean, what would you rather do? Would you rather say, let's say we have an asynchronous operation and we want to say that we've succeeded. Would you rather say return new deferred true, or would you rather say return deferred.success? I mean, I think the second one is considerably more readable, and that's why we're going to put together some of these helper methods. So let's start off. So we'll do a public static deferred. We'll call this one success, and it'll simply be return new deferred. We don't need a return statement, that's implied, with the value of true. And we'll also, I'll go ahead and just write this here. And it's not going to compile yet, but it will soon. Return deferred of t, success of t value equals, or goes into, new deferred. And in this case, we're going to pass in true. And I'm going to be using a constructor. Well, actually, it's a new deferred of t, because this is the second class we're going to write in a moment here that hasn't been written yet. And we're simply going to return true for is valid. Well, actually, I don't know how I want to write this. Let's do value followed by true. There we go. Now we need a failure. So public static fail, and we're going to do our non-generic one first. So fail goes into new deferred of false. Oh, what did I do wrong there? For static access modifier is not allowed for static constructor. Did I just confuse it? Or am I blind? I'm probably blind. Oh. Okay, so one thing to point out here, I'm most likely going to forget a lot of parameter types and return types, and I'm probably going to call boolean or bools booleans quite a bit, and that's because I've been spending a lot of time in TypeScript, and it's hard to it's hard to kind of go back to C# like that. But anyway, sorry about that. I was missing the return type. I was looking. I was like, I don't know what's going on. But I guess my mind was stuck in TypeScript land, which unfortunately or fortunately, TypeScript in some aspects looks so much like C# that it's not difficult to get them mixed up. Anyway, so we have our fail. I also want to do a fail with a string error, which will do false error. I also want to do a deferred of t fail, and this one is going to return a new deferred of t with false. And I don't know if this will ever be used, but let's go ahead and do a deferred of t with a value. So new deferred of t, and then in this case we're going to pass in the value and then false. And I think that's really all I wanted to do. I wanted to do one more. I wanted to do a public static deferred when all with the params deferred, what do I want to call this? Actions. Why not? Now, when all in this case is just going to return null. We're going to implement the when all later. But these ones were so simple to implement that I just wanted to throw them together real fast. I also just made up my mind that, well, oh yeah, I need another one. That's what I was missing. public static deferred of t fail, and we need a string error. Deferred of t, and then we're going to pass in false error, and then we need a public static deferred of t fail t value string error, new deferred of t, and then false or value false error. Okay, so this code, I'll jump back to it once we have the stub of deferred t written so that we can look at it without all those squiggles. And then we have our when all. When all should be a fairly self-evident thing. It will return a new deferred that will be completed when all of the past-in deferreds are completed. So that's a very common thing to write in these sort of frameworks. Anyway, let's move on down and start implementing our methods. So we're going to have our, just like what we had for our IPC method, we're going to need onAlways method. The onAlways method is going to accept an action of deferred, and we'll say result. And I forgot the... I'm just going to say return this. Okay. Then we need our deferred onSuccess, action of deferred result, or actually I'll just do callback for the parameters. And return this. So these will be chainable methods. So we need onAlways onSuccess, and I'm going to do another onSuccess. And this one's just going to take an action callback. So we'll have an onSuccess that returns our deferred back to us, but most of the time when a deferred that doesn't have a value succeeds, we just want to perform some other action after. We don't care about getting the deferred back. So by providing an overload that takes in a callback that doesn't receive a deferred as a parameter, we can write code like this. We can say def.onSuccess console write line done, instead of having to do def on success of, blank being nothing really, console write line done. So by doing that, we save a, we don't really save a few characters because we have to put in the parentheses, but we don't pollute our local variables with adding in a new variable that we're not going to use. So that's why I have both of them. Now we need a deferred on fail. And I'm going to do the same thing here, and the first one is going to take in an action deferred callback, and then I'm going to do another one that just takes an action. Because sometimes we don't care about the return of, or the error or return true? What is that madness? Sometimes we don't even care about the deferred on a failure condition either. Now we need our setting of a result. So I'm going to say public void set result. And set result is going to take in the Boolean is valid as well as a string error. Okay, so the set result is what completes the deferred. So if the deferred hasn't already been completed, set result will cause it to be finished and cause it to invoke all of its callbacks. Now we get on to a couple really interesting looking functions here. So we're going to do a public deferred join deferred next. So what the join method does is it says when this deferred finishes, set the result of that deferred finishing to our own result. Now this is where things get really, really bizarre. Now the awesome thing about the classes we're putting together is they're very, very simple to use, but some of their operations are very, very complex. And, well, not complex necessarily, but very difficult to reason about. The join method is for when we say, when this next deferred finishes, I want to finish myself, basically. Then we're going to have something similar called then. Now, then is a fun one. Then is very, very... This one method provides a significant amount of power to our framework. And the reason for that is it allows you to chain deferreds. So what does then do? Then returns a new deferred that will be finished when this deferred finishes and the deferred instantiated by this callback finishes as well. Now we'll see examples of then and join in the next video when we talk about different examples of how to use this framework. But keep in mind that then is very, very, very powerful and is very important to sort of conceptualize. Anyway, we have a couple other methods that we're not going to write yet. I'm going to comment them in, though, to remind ourselves. So we're going to have a public virtual deferred save of dictionary and byte object parameters, followed by an iSerializer. Now, of course, this method is not going to compile because we don't have the iSerializer here. I'm going to comment it out in a second, but let me go ahead and write my public virtual void load method. Which basically does the same thing and has the same signature. So the save and load methods are used for saving and loading to the parameters for returning a result over the network, back to the client or back to the server, whichever way you're going. And I'm just stubbing them out here so we don't forget about them. And we'll implement them when we move over into the base project, because of course we can't implement them without having a reference to iSerializer, nor can we test it without having a serializer anyway, so we'll do those later. Anyway, so this is our deferred. Now, there's another one that we're going to have to write here. And, oh, I need another then, don't I? Hold on. We need a public deferred of t, then t, func deferred of t, then return null. And that will be our last method stub for this. So this is also, we'll talk about this then in a second here, or in the next video. So let me go ahead and just jump up and just kind of scroll down through the code. There's not a whole lot here, but we have all of our stubs out for this entire framework. Now it's funny how so few methods can be used for such powerful results, but of course we have to actually go ahead and write their implementations first. So before we actually start using this and I show you guys how it's intended to be used, let's write our deferred of t. So I'm going to write a deferred, and I'm going to put a tick in there and put a 1 to indicate that this is a generic type, and it's going to be t. So this guy is going to be t. Let's do t result. I like t result better. And he's going to inherit from deferred, first of all. And he's going to have a couple private fields, a private boolean is value set, and a private t result value. We're going to create our constructors now. So the first constructor is going to simply be an empty constructor, which will basically just invoke the base constructor of our deferred class. There's nothing interesting we need to do about that. However, there are 2 more constructors we need to write. Do I really want to do 2 more? Well, yeah, I do. Actually, I think the way I want to do this here is, let's do 2 constructors. So public deferred, we'll have one that takes a bool is valid and string error, and it's going to call base is valid error, and then it's going to do nothing else, leaving is value set to false. And then we're going to have a public deferred bool is valid string error, followed by a t result. Now this is going to also invoke base is valid error, but he's going to set is value set to true and value to result. You know what? I don't like using value and result like this. So I'm going to change these names. Value is now result, and is value set is now is result set. I really want to keep the terminology consistent between all these different members. So I did change the signature of this from what I was expecting it to be. So let's jump back over into deferred and fix that real fast. First of all, you'll notice that, oh right, this fail isn't going to work because this fail returns a deferred of that, and then this fail, how am I going to do this? I'll just go ahead and take this member off completely. I also need to make sure to supply my type parameters for all 3 of these guys. And then, so on success, what we're going to do is we're going to change this to isValid, so true, null, value. And we're going to call this, we're going to change this to result. And then this fail is going to be false, null, value, and we're going to change value to result. And then this guy is going to be false error, which is fine. And then this guy is going to be I want to swap these around too. I want to do error then t value. And then this guy is going to return a new deferred of t, passing in false error value, and return change value into result. But basically what I did here was I made my method signatures just a little bit more consistent in a way that I like a little bit more. I didn't like having the string error and t result be swapped because, well, hold on. Am I... Right, because that wouldn't follow the order of the constructor of the... No, but it does. Yeah, no, I'm stupid. I'm just kidding. You know what? This is really ugly. Do I want to do it like that? Honestly, that's a little uglier. I don't know. Either way, there are helper factory functions. Not too exciting. We have a couple more things to do on our deferred, though. Because we want to be able to supply callbacks. We don't only want to be able to supply callbacks like these that just return a deferred. We also want to be able to supply callbacks that extract the value that was set out of it. So we need a whole bunch of these overloads that we're going to have to write. So I guess let's go ahead and get started. We'll do a deferred of t return or t result on always. Now this on always is going to take an action of deferred of t result. We're going to call this on always. In fact, you probably should mark this with a new, and then return this. And what are you complaining about? Oh. I'm being stupid. There we go. So then we need a t result on success. So this on success is going to take in an action of deferred of t, and we'll call this callback. And by t, I mean t result, and we'll return this. Let's see here. Yeah, that should be what I want. I think that's probably the only one I need. Then we need a t result of on fail that takes in a an action of deferred of t result callback. And I think that's the only on fail that we need too, because this on fail down here, well, this is going to hide this this on fail. Now this on fail will still be accessible. So that should work. Hopefully. We'll find out. Okay, the next thing we need is public void set result. Is that what I called it down here? I did call it down here. So set result, and we'll have boolean is valid, string error, t result, result. And we'll go ahead and do nothing here. And next up, let's see. We need to do our join and our then. Now our join and our thens are going to be interesting. So we'll need a public void join deferred of t result, and we'll call this next. And then we'll do a public deferred. Now this could be interesting. We're going to have a t result 2. I'll explain this in a second here, and in the next video we'll have a better example of why we need this. So a deferred t result type 2, then that takes in a t result 2. So we're defining a new generic type parameter, and it's going to take in a function that takes in a deferred of t result and returns a deferred of t result 2, and we're going to call this next, and we're going to return null. Okay, so if you're familiar with LINQ and actually have looked into the internals of LINQ, you'll notice that this then method looks similar to the select and select many methods, and that's not a coincidence. The whole sort of way that link works is very similar to how we're putting this together, interestingly enough, to the point where I actually did this just for the fun of it. I put together a couple extension methods on my deferred class that allowed me to use the query syntax for link. So I was able to do something like var ble equals from do operation 1 or from result in do operation 1 from result 2 in do operation 2 select do operation 3 with result and result 2 and stuff like that. That was a really fun thing to put together, but I'm not going to be implementing that in production. But anyway, so you'll notice that then it allows us to transform the return type of a deferred chain. So that's why we have to take in a different type parameter here. But anyway, I really think this is about done. So I'm going to go ahead and hit Control F6 and see that we did build, and we don't have any compiler errors. So I think that wraps up our stub. So let me scroll down through this real fast. So we have deferred, we have our 2 private fields, we have our 3 constructors, and we have our on always, on success, and on fail, and then set result, join, end, then. So the next video we'll actually take a look at some example uses of these classes. So I guess we'll see you then.